Hi, 8th grade. This is Miss B here with lesson 5.2. Today is our second lesson on finding the area of complex two-dimensional figures by finding the area of each shape that makes up that figure. So we're going to begin today by going over yesterday's exit ticket. In yesterday's exit ticket, we have a rectangle whose dimensions measure 48 centimeters by 24 centimeters. And on the inside, we have a semicircle that's inscribed, and that means that each corner of the circle touches, or the semicircle touches that rectangle. So we are asked to find the white region in the rectangle below. So that's everything that's excluding the semicircle. So the way that we're going to solve that is by finding the area of the rectangle and subtracting or taking out the area of the semicircle. So let's go on ahead and set up our work for the rectangle. So we have the rectangle is equal to 48 centimeters by 24 centimeters. So the area of the rectangle is 1,152 centimeters squared. Now to find the area of the semicircle, we're going to use the formula for a first full circle, which is pi times the radius squared. And we're going to cut that in half. We're going to divide it by 2. So we have pi times the radius squared divided by 2. Now our radius is the half of the diameter. And our diameter is a straight line passing from one side through the center of the circle to the other end of the circle. So if you notice, the diameter of our circle is the same distance as one of the lengths in our rectangle. So it's 48 centimeters. So since the diameter is equal to 48, half of that would be 24. So now this was one common error that was made during yesterday's exit ticket. Everybody did a great job in finding the area of the rectangle. It was identifying the radius for the circle where some people got stuck. So we're going to use 24 as the radius. So now we're going to go on ahead and put into our calculator pi times 24 squared, or you can do 24 times 24 and then multiply by pi. So when we multiply everything out in our denominator, we get approximately 1,809 point, we get 55736 and so on, right? But remember, do not round until your very last step. So we need to take whatever this number is in our calculator and then divide it by 2. So we're not rounding just yet. We're going to divide that number by 2, and now we can round to the nearest tenth. So we have 904.77, so that's going to round to an 8 in the tenths place. So this represents the area of the semicircle. So now if we only want this white region, we're going to subtract the total area of the rectangle by the area of the semicircle. And that's going to give us a grand total of 247.2 centimeters squared in the white region. So if you made a rounding error in yesterday's exit ticket, you weren't penalized, but be sure to be very careful with rounding on today's exit ticket because that's one thing that we're going to be checking for. In today's lesson, we're going to continue finding the area of complex figures, and all the problems that you're going to be practicing are asking you to find the area of the shaded region. So we're going to do one more example together involving a triangle. Another thing that you should really focus on today is the organization of your work. As we were checking some of the classwork from yesterday, it was very difficult to find what errors were made where because some of the work was very jumbled and there were just numbers everywhere. So first think about the 2 shapes, or sometimes 3, that you're going to be finding the area of. In this case, we have a triangle and we have a rectangle. So I'm going to set up my workspace for the triangle, and I'm going to set up the workspace for my rectangle for the area of each. The formula for the area of a triangle is the base times the height divided by 2. So I have the base of my triangle, which is 8 feet, and the height, the vertical height of my triangle is 3 feet. So we have 8 times 3 divided by 2. 8 times 3 is 24, and 24 divided by 2 gives us 12 feet squared for our triangle. Our rectangle has dimensions 8 feet by 6 feet. 8 times 6 is going to give us an area of 48 feet squared. So now, since we want the area of the shaded region, our entire shape is shaded in gray. So the way that we would calculate this is by adding up the total sum of both areas. So we have 12 feet for the triangle squared plus 48 feet squared for our rectangle, which gives us a grand total of 60 feet squared. So now, one thing to keep in mind is whether you're going to be subtracting if you have a white region in the shaded region, or if you're going to be adding to calculate the total, just like we did in this example. So you're going to be doing some practice on your own with finding the area of complex two-dimensional figures, and the second station for today will be a spiral review on systems of equations. Have a great day.